Brief introduction of the building. Highland Tower, as is collectively known, consists of 3 blocks, 12-story high apartment named simply as Block 1, 2, and 3, respectively. It was constructed sometime between 1975 and 1978, and the residents who dwelled therein were middle-income earners. Directly behind the 3 blocks was a step hill with a stream flowing west. If it was allowed to follow its natural course. The attraction of this place was the natural surrounding with an extensive view of the city of Kuala Lumpur. Highland Tower collapse was caused by the instability of the pile foundation. The engineer was not considering the horizontal load during design foundation, so when the rotational retrogressive slide occurs, this forward movement downhill creates a surcharge load to the foundation. Since the foundation cannot resist horizontal load, it fell, and as a result, the Highland Tower collapsed. Combination of several factors will contribute to the tragedy of Highland Tower. Tragedies like this can be difficult to prevent. However, certain measures can be taken to protect buildings from landslide. The causes of building failure. Regarding this landslide, the most authentic report has been produced by Ampang Jaya Town Council that MPAJ 1994 Highland Tower collapse main cause is inadequate drainage. From another aspect, design deficiencies also found. The report has MPAJ 1994 following conclude factors responsible for this landslide: buckling and sharing of frail pile foundation preceded by soil movement, surface runoff due to improper drainage facility, cut and fill slope, rubber walls around block I show inadequate design carrying safety factor, and poorly administered construction. Next, slope gradient is expected to be very steep, and last, no maintained drainage system along with leakage from pipe. From the computational analysis done by Prof. Simon, revealed the fact that high wall was very safety factor, and the design wall was felt at 5 meters, very simple, even not including water pressure. The calculated safety factor for all those walls, which were at the back of block I, is 1.52, even without allowing water force at the back of the walls. It is also observed under the same study that wall composed of different size of stone with haphazard plaster carrying no drainage blanket over it. A disquieting point was that it had no base, directly rest on ground. This is the summary of analysis and design method used by the building. Summary of problem-solving recommendation. First is investigated incidents of flooding and mud flow prior to disaster, and quality of design, construction, and maintenance must meet the specification. Thank you.
Around 5:30 a.m. on June 27, 2009, an unoccupied 13-story block of flat building still under construction at Lin Huanan Road and Minhang District of Shanghai City toppled over and ended up lying on its side in a muddy construction field. 1 worker was killed. The official Xinhua news agency said that a 28-year-old worker, Sherneng Zhou, had gone into the building to get his tools and tried to jump out the window when the building fell. He was from Anhui province in eastern China. Construction work on the block appeared to have been nearly completed, with the windows fitted and a tiled facade. Other identical blocks in the same property development were still standing nearby. Initially, it was thought that a 70-meter section of the flood prevention wall in the nearby Dianpo River might have triggered this building collapse.
Causes of the building failure. First, the apartment building was constructed, and then the plane called for for an underground garage to be dug out, the excavated soil was built up on the other side of the building. Next, heavy rains resulted in water seeping into the ground, and then the building began to shift and the concrete wall snapped due to the uneven lateral pressures, and then the building started to tilt, thus final failure of the building.
Summary of analysis and design method used by the building. The rare foundation failure and collapse of the building in China was caused by excavated earth on one side and built up earth and water table on other side, exerting differential pressure on the piles. When the pile capacity exceeded, the piles failed and the building toppled en masse, resulting in a rare foundation failure. It was mainly due to the result of careless excavation very near to the building for the purpose of providing underground car park. Engineers should take note of the lesson learned from this failure and avoid such mistake in the future. Summary of problem-solving recommendation. First, taking into consideration of the proximity near to the river, proper design and construction method should be followed according to the IBC to reduce the risk of failure. Second, special materials and equipment should be used for safety purposes. And then, careful site inspection should be conducted regularly. And the last one, engineers should precisely consider to the geological properties, engineering properties, and environmental properties before designing any building.
Case Study 4 Ground Settlement Problem and Building Cracks Assessment at 88 Unit Houses, Taman Tunas Muda on Lot 6034, Mukim 12, Daerah Barat Daya, Penang. So, for brief introductions of the building, the case study is a project ground settlement problem and building crack assessment at 88 Unit House Taman Tunas Muda on Lot 6034 Mukim 12, Daerah Barat Daya, Penang. This project is carried out in existing residentials house Taman Tunas Muda owned by developer Sri Tunas Harta, SDN BHD, the contractor involved in the housing developments is also under the owner itself, that is Sri Taman SDN BHD. The complex of houses was constructed between 1988 and 2002 and consists of 88 units single-story of terrace houses. The area of the houses is used to paddy field, and the building is constructed and supported by reinforced concrete piles in the foundation structure. Of building failure. Underpinning works. Based on previous site investigations, the building is laid down on 150 times 150 mm square reinforced concrete piles driven down to maximum depth of 6 meter and 18 meter. Because large ground settlement occurred, the stability of foundation has changed felt to resist the load pressure due to large movement. During observation, a sun consultant has found out that since the ground beams were sitting directly to single pile, cap and brick walls is support on the ground beam, cracks appears on the wall and the symptom influence to other structure nearest, then the damage start continuing. A sun consultant also found out that the pile cap also experienced the cracks because of the movement. Based on the study, a sun consultant has designed and proposed the type underpinning being used. The combinations of cantilever beam and 150 mm diameter micropile with 18 mm length was used to underpinning the existing single pile cap foundations. To overcome the problem, a sun rectifications works reports 2007. Pressure grounding. Because of the ground settlement, the ground floor slab becomes suspended. There are empty space which have to fill in. This empty space voids introduce the cracks to the ground floor slab because the floor below the floor cannot resist the pressure from upwards and the loads also. The void is being confirmed below the slab after site inspections. To fill this void, a sun consultant has decided to use pressure grouting to fill the void area under the ground slab. Pressure grouting technique is by injecting the cement slurry to the ground using pump equipment. This method is a common method to stabilize the ground. Pressure grouting has shown because it's more economical to solve the problem. Based on data collected, pressure grouting also can improve the stability of the ground to support structure above. Pressure grouting was carried out in 29 June 2007 and 4 July 2007 using grade 30 concrete explosive mortar flow for Unit 40 and Unit 42. Below is shown the schematic of pressure grouting and diagrams of pressure grouting works. Summary of analysis and design method used by the building. Demi-gauge can measure very accurately, and this equipment is to measuring very small movement. For this crack monitoring, plastic telltale is the equipment to measure. This equipment is very flexible because the reading can be taken without limiting time and no need traditional equipment. The result for this monitoring taken from ICLAM Consultant Monitoring Report as shown on the diagram. Show the overall result of snake monitoring in house 32 using demi-gauge. It showed that the crack is quite stable and sometimes there is no movement at all. But from the value of crack, we see that the movement influenced the opening of the crack in the building. Summary of problem-solving recommendations. The location of the crack is as their physical appearance. Foundation movement often the result in crack at weak point, such as window opening and doors. Secondly, foundation movement tends to distort openings and often cause doors and windows to stick. In some cases, the distortions may also affect partitions, ceiling, floor, and the roof.
Brief introduction. On 27th June 2009 at around 5:30 a.m., an unoccupied 13-story block of dead flat building still under construction at Lian Huanan Foot toppled over and ended up lying on its side in a muddy construction field. One worker was killed. Construction work on the block appeared to have been nearly completed. Other identical blocks in the same property development were still standing nearby. Initially, it was thought that a 70-meter section of the flood prevention wall in the nearby Dianpu River might have triggered this building collapse. The causes of the building failure. First, the apartment building was constructed. Then, the plan called for an underground garage to be dug out. The excavated soil was piled up to the other side of the building. After that, heavy rains resulted in water seeping into the ground. The building began to shift and the concrete pile snapped due to the uneven lateral pressure. The building started to tilt and finally, failure of the building happened. The summary of analysis and design method used by the building. The rare foundation failure and collapse of the building in China was caused by excavated earth on one side. When the pile capacity exceeded, the piles fell and the building toppled mass, resulting in a rare foundation failure.
It was mainly due to the result of careless excavation very near to the building. Summary of problem-solving recommendation. Taking into consideration of the proximity near to the river, proper design and construction methods should be followed according to the IBC to reduce the risk of failure. Special materials and equipment should be used for safety purposes. Careful site inspection should be conducted regularly. Engineers should precisely consider the geological properties, engineering properties, and environmental properties before designing any building.